Hey everyone, welcome to another AP Chem video by the class from last year. So today we'll be covering lab materials, and this video is presented to you by WooJoo, Elijah Steen, Catalina Bartlett, Tara Moore, and Dohoon Lee. Just a quick overview of what we're going to be going over. There's a variety of lab equipment, and these are like basically just tools that you'll see in your everyday chemistry class, and it's good review that you guys know what these are and their uses before actually getting into the class in person. So yeah, that's what we're here for today. Just a few safety measures. Number one, please don't have any foods or drinks while pursuing a lab. Obviously it may contaminate either the lab, whatever, like the volumes or whatever, along with your literal food or drink. Make sure to wear a lab coat. You definitely don't want to get anything on your clothes. Please wear safety goggles. Definitely don't want to get anything in your eyes, because that's going to be very harmful. Definitely make sure to wash your hands. Obviously, that's pretty self-explanatory. Be careful of your surroundings. You don't want to be knocking anything over, messing up the lab, or even lighting yourself on fire. And yeah, just make sure to know your lab materials before getting into a lab. So now we'll be having Elijah with the dropper.
The dropper is a pipette consisting of a small tube with a vacuum bulb at one end for drawing liquid in and releasing it a drop at a time. It is a less controlled version of the pipette, however, as it has a wider end that lacks precision. They are used in the laboratory and also to dispense small amounts of liquid medicines. A very common example of this would be to use it to dispense drops of medicine into the eye. The pipette is a more controlled and precise version of the dropper, as it has a much narrower end. The pipette is used for transporting a measured volume of liquid, and it enables sterile and accurate liquid handling, which is most commonly used within molecular biology, analytical chemistry, and medical tests. Most disposable pipettes hold around 5 milliliters of liquid. Filtering flasks are used in numerous general laboratory procedures for rapid filtration of liquids. Typical flask design includes a conical shape with a flat bottom, tapered neck, and a sidearm for use in vacuum filtration. The flask is great for storing, mixing, and transferring various solutions due to its little sidearm. So cute!
Now we'll be having Tara with the Florence flask.
Here is a Florence flask. A Florence flask, or boiling flask, is a type of flask used as an item of laboratory glassware. It is used as a container to hold liquids with a round body, a long neck, and often a flat bottom. It is designed for uniform heating, boiling, distillation, and ease of swirling. This is a beaker. Beakers are useful as a reaction container or to hold liquid or solid samples. They are also often used to catch liquids from titrations and filtrates from filtering operations. Next is an evaporating dish. Oh no, where's the evaporating dish? Maybe it evaporated? Oh, there it is. Evaporating dishes are glassware containers used for laboratory testing. They are used for the evaporation of liquids and solutions to produce a solid substance or concentrated solutions. The dishes have a shallow, flat, round surface to promote evaporation.
And now we'll be having Catalina with the graduated cylinder.
Narrow cylindrical shape. Each marked line on the graduated cylinder represents the amount of liquid that has been measured. A traditional graduated cylinder is usually narrow and tall so as to increase the accuracy and precision of volume measurement. It has a plastic or glass base and a spout for easy pouring of the measured liquid. Graduated cylinders are often used to measure the volume of a liquid. Graduated cylinders are generally more accurate and precise than laboratory flasks and beakers, but they should not be used to perform volumetric analysis. Volumetric glassware, such as a volumetric flask or volumetric pipette, should be used. as it is even more accurate and precise. For accuracy, the volume on graduated cylinders is depicted on scales with 3 significant digits. To read the volume accurately, the observation must be at eye level and read at the bottom of the meniscus of the liquid level in the Erlenmeyer flask. Such features similarly make the flask suitable for boiling liquids. Hot vapor condenses on the upper section of the Erlenmeyer flask, reducing solvent loss. Erlenmeyer flask narrow necks can also support filter funnels. The final 2 attributes of Erlenmeyer flasks make them especially appropriate for recrystallization. Like beakers, Erlenmeyer flasks are not normally suitable for accurate volumetric measurements. Their stamped volumes are approximate within about 5% accuracy.
Next up, we have the volumetric flask. So what this flask does is for the purpose of mixing solutions, and you would put the first solution in and then fill it up to the top with the second solution and mix them in order to find your new solution. Next up, we have some labs we did in our class this year. First up is the calorimetry lab, where we were able to find the amount of energy or calories that were given off by the certain foods that we burned. Some of the foods that we burned were Cheetos and mini wheats, and here in this image we see that it's a peanut. The main setup is that there's a stand in which you place the food and you light it on fire. This heat would heat up the water, and depending on the amount of water evaporated, it would indicate how much energy was used in the system. Here we have some main things like the thermometer, the beaker, and kind of the whole setup with the stand, as well as the clamps. Another lab that we did was the titration lab. Here we used the beret, which was used to drop the titrant into the analyte, and the analyte's what's in the flask at the bottom. And we would use a stopcock and rotate it 180 degrees in order to let some of the drops flow. And as you continue dropping, the indicator would change color, showing that it's the right pH and showing that the experiment's finished. You guys might be confused because this is your first time seeing this, so we put some images from our actual lab. 2 on the left to show kind of the process of the calorimetry lab, where we would get the soda can and see how much water is displaced and evaporated, as well as lighting the thing on fire and having the whole setup. And the very right image, you have an image of the titration lab, where you have 1 success and 1 failure. 1 failure where we put too much and didn't control the stopcock properly, and it turned into a dark pink. And the light pink one, which one was the correct pH and a success.
And that's a wrap. Thank you for listening. That was a long and pretty probably boring video. I hope you guys still learned something. And please, if you guys want, watch this video anytime you guys want so you can have a nice little review. Thank you.